Yeah. So good morning, good afternoon, and good evening, everyone, based on your time zones. Alright, everyone. So welcome to today's class on NLP. If you remember, the last class had stopped at the conceptual level. We did not dive into the project, and we thought of completing that project in this class. So that is what this class is for. Just an extension of the last week's class. In this session, we are going to understand, once again, just to recap what is NLP, why it matters, how text is cleaned and processed, how text is converted to numbers, and how machine learning can classify text. So by the end of this class, you should understand the complete basics of an NLP workflow. NLP is a very big topic. Whatever I'm teaching you in NLP, as just a precaution, I'm telling it in the beginning, it is only for interview and a junior job level position. That is the aspect I'm teaching you. But in fact, NLP has lot of sub branches. NLP is diverged into lot of things. It takes months and years of time to diversify and to learn all of those, but instead of doing that, we are learning the most important concepts and the complete workflow of NLP. And we will be working on a full project implementation, and we already know about what we are going to do and all. So this is what we are going to do today. We are going to load and explore. We are going to clean the text. We are going to vectorize. We are going to train the models using our last class discussion, naive and logistic, and we are going to evaluate. And finally, we are going to live predict on the movie reviews. So this project is going to be on movie reviews. Movie reviews. So just I'll give you a recap of what is NLP. NLP stands for Natural Language Processing. It is a branch of AI. This is the part that will help computers understand, interpret, and work with human language. And one of the example that I provided in the last class is that a child understanding what you are talking. The communication between you and a child is nothing but NLP. As simple as that. You can talk in any language. It can be any mother tongue across the world. It doesn't matter. But the child automatically picks up the language, right? By the time the child attains 3 years. So that is NLP. The child able to understand what the mother or the father is saying and replying back to it via channel of communication. It can be any language again, is NLP. This is one of the question that was brought up to me by a student in one of the class. Here all we do is in English, right? The coding we do is in English. The training happens in English and all. So the question is is NLP only talks about English language, or it can be on any language? The answer is it can be on any language. It can be on Hindi, it can be on Marathi, it can be on Telugu. It can be on any language, not specific to any English or anything like that. NLP is just about communication. A computer understanding the communication part of humans is NLP. So whenever you're using Google Translate, Chat GPT, spam filtering, search engines, voice assistants, you are interacting with NLP system in every day of your life. Now, the challenge is that human language is clean. I also brought this up in the previous class. As a human to human, whenever I do a joke, whenever I do a sarcasm, you can easily understand it, and you will be understanding the context. And based on the relationships also, the words meaning completely changes. I gave an example of when a friend calls you and tells you to come to the bank, and when a girlfriend calls you and tells to come to a bank. Is completely a different context. Here, bank can be a financial bank or it can be a river bank. So these are two different aspects and it completely changes because of the relation and the context. So and humans are very good at understanding this. Even a 3-year-old child can understand whenever you're communicating with language, right? Because the child can see your expressions and the child can pick up few things. But for a machine, it's not that possible. So with NLP, we are going to use some particular techniques to make the machine understand all these different things. And as I said, language is messy, and the same word can mean different things in different contexts. People use sarcasm, slang, abbreviations, emojis, spelling mistakes, and mixed languages, all these sorts of things in human language. But the beauty is humans understand it, whereas machines find it very difficult to understand all these things. And this is exactly why NLP is interesting and also difficult at the same time. So any doubts still here on NLP? No doubts, right? Okay, but if I have any, please let me know. Okay. Okay, I just got a message that one of our friend is joining. Just 2 minutes. Yeah. So I told you what is NLP. Okay, let's also think about NLP pipeline. So let's understand the standard NLP pipeline. Almost every NLP workflow follows this structure. First, we have a raw text. Second, we clean and pre-process it. Third, we convert it into numerical features. Fourth, we train a machine learning model. Fifth, we evaluate this model. And then finally, we use this particular model to predict on the new text. So throughout the whole class, we keep this flow in mind. So how it goes is like, there will be a raw text, we will be sending it to pre-processing, we will be sending it to feature extraction, we will be sending it to model, and we will be sending it to evaluation, and after evaluation finally we will be doing the live prediction. This is what the pattern we are going to follow. And am I missing something? Yeah, why pre-processing matters. Again, this all of this I've explained it in the previous class, but just to again recap, machine learning models cannot directly understand raw text. They cannot understand the meanings. I mean not the meanings. They cannot understand that love, loving, loved. For example, in a sentence, if loved comes or loving comes or love comes, you know that they are all related, right? All these three words are related. They're just adverbs and adjectives of the same word. But the machine cannot understand it. Machine doesn't have the entire grammatical concepts, so they don't understand this, and they do not know what punctuation, URLs, hashtags, and stopwords often mean also. So before we train any model, we need to clean the entire text carefully. And that cleaning process itself is called pre-processing. If you don't do pre-processing, if you don't do cleaning, the communication won't be good. Same on what you do to a child. Whenever you talk to a child, you talk so carefully, right? Not to, I know, use any bad kind of words or something like that. You be conscious to yourself when you're talking to a child, where your mind is automatically doing pre-processing on your language. The way you talk to your friend is going to be completely different. The way you're gonna talk to your child is going to be completely different. So the difference between what you actually talk and what you're delivering to the child is what pre-processing cleans up the unnecessary or unrelated stuff. Next, yeah, so this is done. Why pre-processing also I told you. And pre-processing is one of the most important steps in NLP, because a bad pre-processing pipeline often leads to a very bad model. And I told you about tokenization. Again, I'll recap quickly. So the first step in pre-processing step is tokenization. It simply means breaking text into smaller pieces, and that smaller pieces are called tokens. These tokens can be sentences or word. If you take any paragraph, that entire paragraph can be divided into sentences, and sentences can be further divided into words. So this the division and the individual elements is called tokens. So this matters because most of the later operations that we do, like removing stop words or counting words, happen at this token level. They all happen at the token level. And I covered tokenization. And one more important topic in NLP is stop words, which is an easy question in interviews. Like, what is the concept of stop words, and why we need to eradicate stop words and all. Stop words are very common words like the, is, and, of, to. These words appear in almost every sentence. So for many NLP tasks, they do not help us much. If the goal is text classification, keeping too many common words can add additional noise to increase the feature size, and without adding actual value. Again, the same example when you're talking to a child. You don't use proper English and all, right? You try to make things easier for the child to understand. So the same thing even happens here. And that is stop words. So in many NLP pipelines that you see, even in internet, traditional machine learning pipelines, we remove stop words. We always remove stop words in any of the pipelines that you see in my class or in internet or anywhere. But remember always that this is very task dependent. Monesh, can I remove stop words in all of the projects that I do? No, you cannot do that. Only based on the use case you can remove the stop words. In our use case, in this particular project, stop words doesn't make any sense, so I remove it. What is another concept that I'm forgetting? Tokenization done, stop words, lemmatize. Stemming versus lemmatization. So both are methods to reduce words to a base form. Stemming is a rough process. I told you when to use stemming and when to use lemmatization. Stemming is a rough process. It cuts off endings and may produce forms that are not actually dictionary words. Like, for example, studies will be converted to study, STUDI. Lemmatization is intelligent, but it will take more time. So based on your use case, you have to think to use stemming or lemmatization. But I always suggest my students to go with lemmatize. And today also, in today's project, we are going to use lemmatize. So full cleaning, this is the pipeline. Full cleaning pipeline, I'm not going to talk again. I already talked about it. It's going to be long. Like converting text to lowercase, removing URLs, removing hashtags, punctuations, tokenizing the text to, removing the stop words, lemmatizing the words, removing meaningless tokens and all. Bag of words I discussed. If you have any doubts in bag of words, TF-IDF, n-grams, You can let me know, and I'm happy to repeat them. We also discussed why I'm going to use these particular models for NLP, like logistic regression and NIBIS. NIBIS is simple. Logistic regression is strong baseline. That is the reason I'm using these two. Anything more I'm missing before starting the project? Yeah, I think I covered all. Any doubts from anyone? Any doubts till here? All good. Okay. But yeah, please, if any doubts, let me know. Okay, then data set, and we'll start the project. Again, if you forgot what we are doing, what project we are doing today, our goal is to classify movie reviews as positive or negative. We will use a labeled data set called movie reviews, and this movie reviews comes from NLTK. Already from NLTK library, we'll be using this movie reviews data set, inbuilt data set. And yeah, this data set is great for teaching, and also this data set I already told, right? It is very balanced, it is clean enough to use, already labeled. We'll do this project, and we'll use the complete full project pipeline that I prepared. This one. Yeah, I think I can start then. But if any doubts, please let me know. You understanding NLP is the main core aspect here, because NLP is one of it's like heart of AI. If you don't get the NLP part, I don't think moving forward you will get agents also. The next classes the next class is going to be on storytelling. How to build graphs, how to form a story, how to the entire art of storytelling and prompt engineering is going to be the next class. Once after that is completed, we are going to dive into proper AI. Till here, you are just teaching a child, communicating with a child, feeding a child and all. After the next class, I think from next week, you are going to learn, you're going to deal with a 5-year-old baby. It's not going to be easy. 5-year-old child. The child is going to get consciousness, and the child is going to ask you questions now. A lot of questions the child asks you, and you have to be prepared for it. For that preparation, I'm gonna teach you some frameworks like LangGraph, LangChain, and LangSmith to make you ready. So that is going to be next week classes. Okay, on the day I was using this to teach you the code part and all. I'm gonna use the same Google Colab. Since I already have completed the project in last week class, I mean myself I have completed it before teaching to you. I embedded all those code into this presentation. So yeah, I'll copy paste and I'll explain each and every part of this. We have already used this code, right? Yeah.
Monish, can you hear me?
Yes.
Can we, before dive into, can you explain? I think I just not able to recall the two cell codes that you have written down. What it is doing. I just want a little recap on those.
These two, right?
Yes.
Okay.
Wow.
This one. Okay.
Yeah, that part. Yeah.
Yeah.
If you can just give a recap on that. Thank you.
Oh yeah. So these are the bag of words TF-IDF and the n-grams that I was talking about. So once we have clean words, I mean once the pre-processing has done on the top, like you removed the stop words and we did the lemmatization. After lemmatization, we have done the pre-processing step. Once after the pre-processing step is completed and after removing all the unnecessary stuff, then once we have clean words, how do we give them to a machine learning model? How we are gonna give love movie to a machine learning model? And that is where feature extraction comes in. Feature extraction has types. There are different levels. Bag of words is one of the simplest ways to convert text into numbers. Bag of words, BOW. And the next one is TF-IDF. There are some limitations to bag of words, and for those limitations, we implemented something called TF-IDF, which improves upon bag of words. And after that, there is also one more useful concept called n-grams. We are going to use all these three different types, and I have shown you how to do each one of them. This is bag of words. This is oh no, I think this is not bag of words. Let me once open the presentation. Then I teach bag of words on the day?
Not that I recall. Maybe you might have.
Yeah,
Okay.
Okay. Vectorizer, yeah.
All right.
I should have written comments here.
I usually write comments, and I think I did not do that last.
And let me put it quickly. This is bag of words, feature extraction. So what bag of words does is, the idea is simple. We create a vocabulary of unique words in the data set. Then for each document, we count how many times each word appears. For example, I love NLP and machine learning. You divide these words into columns. You put it into columns. All these different words that you see, you convert that into columns. And now let's take the first one. I love NLP and machine learning. So where is I? Where is I in this? There is no I because it has been removed by our pre-processing step. Now look for love. I think definitely love is going to be here. So we gave a 1 here because love is present in the first sentence. We gave a 1 here. Next NLP also gets 1. And I think there is not going to be any end. No, and is being cleaned by the pre-processing step. Machine. So machine gets 1. Learning gets 1. So whatever the vocabulary that is present in the first sentence gets 1. So 1 1 1 1 and there is also end 1. So whatever that is present here, it gets 1 and the remaining all gets zeros. So this gives us a numerical representation of each document. And bag of words is easy, simple, powerful. But again, the major limitation that I said in the previous class also is, if you take a word not good, the context of not good is a completely different thing. Good is different, not good is different. These two are polar opposites. But bag of words cannot understand this polar opposite. So that is where TF-IDF comes into place. This is the code for TF-IDF. So TF-IDF improves on bag of words. TF means term frequency. Yeah, TF means term frequency. IDF means inverse document frequency. So how rare each document, how rare each word is present in the entire data set is being calculated, and usually it goes from 0 to 1. That is how it goes. So it gets better. I mean, bag of words is good, TF-IDF is better. So most of the time everyone try to use TF-IDF. Don't go with bag of words. And then this is n-grams. N-gram is another useful concept of feature extraction. N-gram has 3 different types: unigram, bigram, trigram. Unigram means single word, bigram means consecutive words, trigram is 3 words. Monesh, what are you talking about? What is this one? Unigram, bigram and trigram. If you are tokenizing as single words, it is called unigram. If you are tokenizing as 2 words, it is called bigram. Means maximum it can be 2 words, then it is called bigram. If you are tokenizing max with three words, then it is called trigram. So in this particular code, what we have done, amazing is 1 word, amazing for is another word. These two are treated as 2 different things by the machine. Good is one word, not good is another word. So not good has its own importance, good has its own importance. So using bigram is much more better than this TF-IDF. The extension of TF-IDF is nothing but your n-gram. So these are the 3 different future extractions you have. And my suggestion is, if your wordplay is simple, go with TF-IDF. If your wordplay is more complex, go with n-gram. Don't go with bag of words at all. Bag of words will give you a lot of problems moving forward. Yeah, any doubts still here? And if you're wondering why there are 3 decimal places and all, I have given it in the code. If you want, I can just round it off to 1 as well. Usually n-gram and TF-IDFs, whenever you're checking for the, what do we call, the repetitions, how many times it's being repeated, TF-IDF uses a 3 decimal pointer. So I've used 3, but there is no rule like that. You can use 1 also. It will round up to 1. But using 3 is the standard. Yeah, any doubts too? Did you get it, Kamala?
Yeah, exactly. Yeah, I think it was a little off for me from last cluster. Yeah, now I can follow. Yeah, thank you.
Yeah, thank you. Okay. Oh yeah, I already have the code, right? And NLP projects are not going to be so big like the other projects, because the base concept of NLP, like 10 to 15 years back, it used to be very big. I mean, the base level coding and all. But after when the libraries were created, like this TF-ID vectorizer and all, things become so easy. I mean, what I'm trying to prove is you don't need to write a bigger codes. If you take the same concept like 15 years back also this existed. But if you were doing 15 years back code without this TF-ID vectorizer, before not using this bigrams and all, it used to be a very big task, because manually you have to use for loops, and you have to get the new words, you have to check for the strings, and then you have to divide them, you have to separate them, then you have to count them. So it's a very, it used to be a very big code, like 40 cells, 50 cells of code. But by using these libraries, this project is not going to be too big. It is a big project conceptually, but for coding it is not so big project. I think max in 10 to 15 cells this project will be over. So this is the code I had for the last previous class, but we did not use it. I'll be using it now. Oh yeah. So here you can see that I mean, this code is a bit self-explanatory, but I'll just go through it. Um, or should I leave this code? Okay. And I know this is very self-explanatory code, but I'm just going line by line. We have a reviews empty list, and we create an empty list to store the review data in this. For field, it's a loop, loops through every review file in the data set, and this particular, it assigns 1 if if the movie review is categorized to positive, then we label it as 1. If it is categorized to be negative, then we put 0. Actually, I think it would be better once I show you how the data set looks like.
So Monish, is the data set already categorized like to the positive and negatives?
Yeah, it is already categorized.
Okay.
So it's in root NLTK data. NLTK data corpora overviews. Let's download desktop. So you can see here, this is how the data set looks like. The movie reviews folder, whatever the zip file we have, inside it there are 2 different folders. One is negative and the other is positive. Already the data set is categorized. Whatever the data set that already being categorized, we are using it to train our model. So if you take negative, let's click on something. You see the plot, you see the critique, what the critic has told about the plot and all. You can just read it by yourself. There are going to be a lot of gibberish things and all, or people chasing the blah blah something stuff and all. And the person who have made this data set, who have created this data set, said us that this is a negative review. This is a negative review. Why? Let's see. So Melissa running is just playing lazy. So you will get the context when you read the files. You will get the context on why it is a negative review and why it is a positive review. So in our data set we have 1,000 negative reviews, 1,000 positive reviews in our particular data set, and we are labeling 1 to be positive, 0 to be negative, and we load the full review text, and for the text we are putting the label whether the text is positive or negative from the label that we created on the top. We are converting the entire reviews into a data frame, and that data frame, what we are doing here, we are converting the list into a data frame, and we are shuffling the rows. If you don't shuffle the rows, the problem happens is it's like you reading 10 important questions and answers, and you are going for a mock exam, and the 10 questions and answers will come in the same order. That is what the problem happens. So it's always better to shuffle all the rows, and we use random state 42 to shuffle the reproducible, and reset index is used to reset the row numbering. So to work on it's just simple. We have to work on the data set. We changed it to data frame. Any doubt still here? I'll give you some time, like take 5 minutes of time. whatever the data set we have, just download it, like how I downloaded. Click on three dots and download it. Look at the negative and the positive folder. Look at the text. Look at what is written here, because this is very important moving forward. First, you have to understand what is the data that you're working on. I'll take 5 minutes of time. Unzip the data, open it, and read at least 3 negatives and 3 positives, so you'll get a context on what you're dealing with. Yeah, do it now.
We don't have to download, Monish. I think Google Colab lets us to read directly.
Here, I'm not able to.
Yeah, you just click on it, it'll let you read those.
Okay. For me, it is taking a lot of time.
For me, it's already instant. It's pretty. Yeah.
Yeah. So yeah, you can see there are a lot of unnecessary words, unnecessary punctuations, unnecessary stop words and all, which takes up a lot of space and all. So that is the reason we are using stop words and all, to remove the unnecessary stuff. Yeah, total reviews are 2000, positives are 1000, negatives are 1000, and the average words and in the entire data set, the average new words, individual words, are 640 around approx. Now we start to explore the data. Yeah, but till here, any doubts, anyone till this? Seb? Okay. Well, now let's then. Okay, so d of length, d of text dot apply lambda dot split. This creates a new column called length, and for each review it counts how many words it contains, this particular line. For each particular review, it calculates how many words it contains, and this axis creates a figure with two side by side plots. To create two side by side plots, we use this plt.subplots. One row, two columns. That is what this 1, 2 represents. One row, two columns. So the first column is going to be a pie chart where I'm just showcasing how many positives and negatives are there. And second plot, I'm showing a histogram on how many words. It's like what is the right? It's like an histogram showing the review length distribution. For example, a thousand word length of negatives are like for around 30, but positives are around 40. That's the difference. So what is the length of distribution we have for the reviews of positives and negatives is this right side plot. Histogram to show review length distribution, a pie chart showing positive versus negative counts. Yeah, any doubts till this one? Okay. Kamala, like yours is like normal Google Colab only, no?
It's a regular Google Colab.
Okay.
Yeah.
Because I remember from the first, I mean, for this batch from first class also, like for every time for us, it used to take time to load the.
Right.
Just,
No, mine is as usual the way you do. It's just two different results.
okay. Yeah, in the back of my mind, this is running. So.
No, it's the same. Yeah.
Okay, so after the plots, we clean the data using this particular function. Yeah, the clean text function that we have written on the top. I'm going to call that on every review, on every text, on every single text of our data set. We are gonna call the clean text. I think I have code for that. Yeah. I already have this function on the top, but when I was working on the project for the first time last week, at that time I don't have this prepared, so I put it in the presentation. Okay, so you can see that 2000 reviews have been cleaned. It is completely done. And before, this is how this is just an example that I randomly taken, the first one from the 200. So before, you can see here that spine chilling, drama, horror, Stephen King, comma, and all blah 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 blah, blah stuff. This is before the pre-processing, and this is after the pre-processing, which looks much more cleaner and neater. But from a human perspective, you won't understand this much. Again, a small thing that I want to clarify. From a human perspective, you may feel before is much more better because we like punctuations, we like full stops, we like hashtags and all for context and all. But computers don't like them. So computers understand this more better. Coming to the code part, clean text, I already you know what we have done to achieve this function. We have used TF-IDF on real data and split. We have used TF-ID vectorizer. with max features 5000 and n-gram range. I think my screen share stopped. I'm resharing. Yeah. So where am I? Yeah, we have done all these things, that whatever we have discussed in the previous class, like stopwords, lemmatizer, and all, and we just called it on every single text of the dataset. Simple. And after cleaning, so the complete cleaning is done. All the thousand positives and 1000 negatives are converted from, I mean, noisy data to clean data. What is the next step after cleaning? It is TF-IDF trend test split. So we will be using TF-IDF vectorizer to first convert the text into numbers, and after converting the text into numbers, we are going to do a train test split data for training and testing. Any doubts in this code, let me know. Okay. So vectorizer TF-IDF vectorizer creates TF-IDF features for real reviews. It limits the vocabulary to up to 5000 words. That is the word I mentioned here, 5000. What is this 5000, Monish? So it doesn't matter how many words, how many different vocabulary the dataset has. If I limit it to 5000, automatically TF-IDF adjusts itself to handle only 5000 vocabulary data. It can be 1000 in let's say in real dataset there are thousands of real vocabulary, individual vocabulary, but the 1000 will be converted somehow, like combining, doing bigram, doing trigram, by using this trigram, bigrams and all, they will be converted to 5000. So max, what I'm saying is, it doesn't matter how many vocabulary I have, maximum I should have only is 5000. I'm fixing it. Why do we fix it? If you fix it properly, the computational power is handled well. If you don't put any max value, right, there may be sometimes 10,000 features, 10,000 unique words in dataset, and that overcomplicates things. So you can adjust yourself based on the use case. So here I said it is 5000. And what I mentioned here is 1,2 means I'm saying you can also use unigram and you can also use bigram. You can use only one word or you can use 2 words max. That is what I'm mentioning here. And I've used TF-IDF. Next. Yeah, here I'm fitting. I mean, whatever I mentioned here, I'm creating a fit here. Converts all cleaned reviews into TF-IDF features, this line. Then it stores all the labels separately as target values, because whatever we see in the dataset, label is the target, whether it is a positive or negative. And then this part you already know, X-train, X-test, Y-train, Y-test. We are splitting the data into training data and testing data. 0.2 means 20%, random state 42. Stratify, yeah. Stratify Y preserves label distribution in both sets. What is label distribution in the sense? If you don't use this stratify Y, right, there might be a chance in training data there can be more positives, in testing data there can be more negatives. There might be a chance. So when you use stratify equal to Y, right, it keeps good balance. In training data, there will be good number of positives and negatives. In testing data also, there will be good number of positives and negatives. To keep up that balance, we use stratify equal to y. That is the main purpose of it. So train data has 1600 reviews, test data has 400 reviews, and maximum features that we allowed is 5000. Here features means words, unique words. So any doubts on vectorize and split, where we are in the pipeline? In the pipeline, we are here. Step number 3. Load and explore is done. Clean text is done. Vectorize is done. TF-IDF, I'll be using 5000 features with unigrams and bigrams. Any doubts till here? I also wrote like what each one does. So when you're going through, it becomes easy. Yeah, any doubts still here? Okay. Yeah, but if you have any, let me know. The next step after vectorization is training the models. Monish, what is this? Very small code. It is small code because we are using Python libraries. But I still remember. I mean, I looked at the older codes without I mean, you can also try to check them. Just go to internet and try to do naibice without using the multinomial NP library. You will see a very big code, like around 16 cells of code just to train a naibice without using this multinomial nb.fit. But you no need to learn the older codes now. They are outdated. For over, done. Training is done. I don't think I have to bring back what is logistic regression. You already know, we have already done projects on logistic regression. Multinomial naive. So this particular code that you see here, NP equal to multinomial NP alpha 0.1, creates a naive model. Naive is one of the distribution algorithm that I've discussed in the class 2. And here alpha equal to 0.1 controls the smoothing. The more the number, the more sharper it becomes. But 0.1 is the standard alpha for multinomial NB. I think you already know what is max iter. Max iter is nothing but enough iterations to coverage something. C equal to 1.0 is the regularization strength of this max iter. Yeah, we have already done this in the previous projects. This is something new for you, multinomial NB. So yeah, both the models are trained. Once both the models are trained, the next would be evaluating and comparing the models by using confusion matrix. True negatives, false positives, false negatives, true positives. We're gonna evaluate them. And I forgot to mention to you in the previous class as well. In the Neuralin Academy website, Q&A has been opened. I mean, the quiz and the tests are opened, uh, and also there might be an exam. Don't take it too serious. Just a normal exam, which will be conducted just to test. Those are opened in the portal. Just go and check out. Uh, yeah, as I promised at the end, who has scores more, there will be a prize. I'll give you something for that. Okay. Next step is evaluation. So we use it the train model to predict the labels for the test set. Same, exactly the whatever the code that you see here is exactly the code that we use for older projects. Same code, no difference. Model.predict X test, accuracy score, Y test pred. Same. In older code also, if you go and check, we have used the same thing. Monas, then what is this? Here I have just used a visualization to show you neat in a neat fashion, like the two different algorithms, how their confusion matrix looks like. Naive, the accuracy is 81. Logistic regression is 85.5. And you can see the true positives, true negatives, uh, oh, no. False negative, true negative, uh, what is this? True, positive, and negative, right? So it is false, positive, true, positive. Yeah, all the four that you have here. I have explained it here as well, what each one represents. Um, why I have written 83, 87? I don't know what I did different, but there I got 83 and 87. I think when I was working, I made maybe some different thing and I got 83, 87. But here right now I'm getting 81, 85.5. Yeah, so this is our evaluation. After the evaluation also you can do multiple, you can do multiple charts to explain, like you can do also a pie chart to show which one is better and all. So after the evaluation, do you all remember what is precision, recall, and F1 score, or you want me to repeat? It's up to you.
No, I think no, I got very clear
Yeah.
because you did the entire class.
Thank you. So this is done. Yeah, once evaluation part is done, if we go to the pipeline, load and explore done, clean text done, vectorize done, train models is done, evaluation is also done. We took the accuracy, precision, recall, and the confusion matrix. Now finally, the last step is live prediction. Live prediction happens very differently in our personal projects and in the job, in the actual job. In the actual job, what happens, I'll tell you, we will have a pipeline. You whatever the model that you have created, that model exists in some form of server, and there will be a pipeline, like how GitHub has a pipeline. There will be a pipeline attached to this particular model that you have created. Whatever the new movie reviews that will come to your application, automatically that movie review goes into this particular pipeline and there will be an output that is so live. It runs 24/7. So whenever you put a review, automatically it goes through it. But whatever the live prediction that we are doing now is like I'm sending something and we are getting an output. But in work, you are going to see much more dynamic. So we'll predict on brand new text. I think today's class will over soon. Nice. So we are predicting a new text. Here I've written a new function. So what I've done is, when I get a new text, the model that I'm going to use is logistic regression, LR. You can see here I've used LR. Here, LR. So with logistic regression as the model and the text, I'm cleaning, I'm vectorizing the features, I'm doing a prediction, and whatever the prediction I made, if it is positive, I put a tick mark and say it is positive. If not, I put it as a negative. 1 is positive, 0 is negative. And confidence is nothing but whatever the probability that I got, I did into 100. So you can see I have done the print statements here, and you can see this movie was absolutely incredible. Our sentiment model thinks it is negative. Our model thinks it is negative. This movie was absolutely incredible, and our model thinks it is negative. On of a confidence level 50.8. If you remember what I said in the very beginning of the class, I mean not today's, last class, even if your NLP is wrong, and if the confidence level is low, that is still fine. That is still fine, because you still have the scope to use better algorithms, to use better, you can do fine tuning, and you can increase this confidence level, and automatically it gets the correct answer. The problem comes when your sentiment is actually wrong. For example, let's take the second one. Terrible film, waste of 2 hours, which is a negative review. The text is really negative. In a real perspective, it is negative. And what our algorithm thinks is also negative, with a confidence of 74.9, which is great. This is good. The second one is very good. It has categorized correctly. The third one, let's see. It was okay, not great, but not bad. So in a very normal terms, we call it average, but we don't have average in this particular data set. We have only positive or negative. If it is really great, it is positive. In all the other cases, it is negative. So third is also fine for me, because what it says negative, which is correct, and of a confidence level 60.7. With the last two, I don't have any problem. They are correct. But I have the problem with the first one. But the first one also is not a problem, is what I'm trying to tell you. Why? Because the confidence level is so small. It is 50.8. Only by just 0.8%, it has converted from positive to negative, which is completely fine because the confidence level is low. If your confidence level is high and your answer is wrong, that is where the real problem always lies. If your confidence is low and if it is a negative answer, it is fine. It's not good, but it is fine. But these two are great. This is great because the confidence is high and the answer is also correct. Here the confidence is bit low, but still the answer is correct. This is, I would say, it's not very bad, but it's okay. I understand 50.8 is just to the border. And it's okay, it's fine. And that is why our models did 81 and 85. I don't know if I put it here though. Yeah, I did not put it here, like regarding the 50.3 thing, but I'm just telling it verbally. So this is also fine. Yeah, let me also show you VADER. This is like a bonus, this last one. Resharing the screen. This is the code I copy pasted? Right. Where is the from import? Oh, I already imported the VADER. Okay. Monish, what is this? What is this VADER bonus you're talking about? Now the project is done. But I wanted to talk about something called VADER. VADER. This is something that I've discovered just like 1.5 or 2 months back in NLTK, and I felt it is pretty useful, so I wanted to share it with you. And this is something now most of the ML engineers are also working on. VADR, I mean, you can, if you want, you can write it also somewhere. I'll also put it here. VADR, it stands for Valence Aware Dictionary and Sentiment Reasoner. Yeah, correct. So it stands for Valence Aware Dictionary Sentiment Reasoner. This VADER is particularly used on sentiment analysis or any categorization like true, false, lie or not lie, positive, negative. In these kind of classifications, sentiment classifications, VADER is very useful. It is a rule-based sentiment analyzer that is inbuilt into NLTK, and the beauty of it is it requires zero training. You no need to train nothing. There is no training at all. It's like the child was born with intelligence. You no need to teach the child anything regarding communication. Like a gifted child, the child already know the language when during the birth itself. You no need to teach again. So that is what VADER does. VADER doesn't need you to train it again. It uses a handcrafted dictionary of words with pre-assigned sentiment scores. It has a dictionary inbuilt and it has a sentiment scores already inbuilt into it. It works especially on short, how do I put it in correct words? Social media text. Whatever the social media comments you see, I'll give you best example. Abba. In YouTube, go to any video you like, type a very bad vulgar comment. I mean, don't do it really. I'm just telling as an example. If anyone goes to YouTube and puts a vulgar comment in English language, go and check it in the next day. It won't be there. Automatically, YouTube comments will remove it. Have you ever wondered how it does that? It's because of something called VADER. Automatically, it understands the sentence without training. Again, whatever I'm saying, it is without training. Without any model, without any training, automatically VADER detects the words. It understands what each word meaning. It understands, like, for example, terrible means negative. Bad means negative, something like that. It has an inbuilt dictionary, it has an inbuilt structure and sentiment scores for each of the words, and automatically it works on short sentences like YouTube comments, Instagram posts, and all these sorts of things. VADER is a very good concept, very good concept that is there in NLTK. And let's see the code that I've used. You can see I've never trained anything in the entire code. I imported VADER on the top. This SIA sentiment intensity analyzer creates an instance of VADER in the variable SIA. It internally loads a lexicon. VADER loads something called lexicon. I'll write it here. Also loads lexicon, and lexicon has, I mean, by the time not now, like 2 months back when I was researching about this VADER, it has around 7,500 unique words for the time when I was researching. I don't know how many of them were now. And those approx 7,500, those 7,500 words each are mapped to a sentiment score, each of them. And words, for example, like incredible have a high positive score. Terrible has a strong negative score. Incredible is a highly positive thing. Terrible means highly negative, right? So automatically it has those scores inbuilt. You no need to train it again. And once this is done, I have taken some test data, like some random sentences, and I've used a for loop and have called polarity scores of each one of them. Polarity scores of each one of these reviews. So each one is calculated. If it is greater than 0.05, I told it is a positive. If it is less than 0.05, it is negative. You have to remember this. 0.05 is the base. 0.05 is also fine. 0.05 is also positive only. Anything lesser than that, it is negative. It goes to negative in VADER. So, and also one more thing. If you check here, I have never cleaned the sentences also. I never call the clean text. You observed it? You don't need to do pre-processing in VADER. That is one more beauty. VADER doesn't require pre-processing. VADER doesn't require model training. Just raw text. You give raw text, automatically it will give the sentiment analysis answer of it. That is why VADER is very popular. It's used widely in real time, the Instagram, YouTube and all. If you go and do a research, it all uses VADER somewhere in there. So very useful. You can blow interviewers' mind by talking about VADER. So yeah, most of them don't know about VADER, but it's a very useful technology. I think more. Yeah, I wrote here as well. No training needed. Fast struggles with the domain specific knowledge. Yeah, this is one more problem. I mean, I was hyping about VADER, right? All the positives. There are also a lot of negatives. VADER doesn't work on our non-English languages. Like if you take Hindi, Telugu and all, it doesn't work. VADER is made for English. So whenever you go to a specific language, right, VADER fails. And that is the reason you can put vulgar comments in Instagram and in YouTube in your language, in non-English, like Telugu and Hindi, and it stays there. But the moment you put it in the proper English, then only like YouTube removes it. And this was the reason of it. For specific languages, VADER doesn't work. It's not trained on that. And also domain specific knowledge, in the sense, if you take medical terminology is so vague. It's so, you cannot put every word of medical terminology into this VADER and all. So in domain specific terminologies also VADER fails. So these are the two different things where VADER doesn't work properly, and our original training data works there. Yeah. So I know that the class is going to be a very small one. I want you to perform these three things. So in 5 minutes there will be a break, right? We'll take the break, and after that, you on your computer in your Google Colab, whatever the code that we have here, which I shared already with you. The first one you have to try out is put TF-ID vectorizer maximum features. I have used 5,000, right? You put 10,000. Put 1,000 or 10,000 and see the difference. If you are putting 1,000, then what is the output? If you are using 10,000, then what is the output? You try to play with it. And for replace this TF-IDF with count vectorizer, I mean the bag of words. Don't use bag of words in your real projects, but for experiment, just convert the old TF-IDF code that is there in this with bag of words and see what happens. And give a sarcastic review for testing purposes here and in here. Give a very sarcastic review in your own terms. We all use sarcasm, right? Like here I gave an example. Oh great, another boring film. So here I mentioned oh great. So the model thinks it is a positive review, but as a sarcasm it is a negative review. So you give a sarcasm review and see if it comes under positive or negative. So yeah, this is something that I want to do in the class. Yeah, we'll take a break. Let's take a 15 to 20 minute break. We'll come back. I'll be here. You try it in your system and you tell me what your outputs look like. You can put it in this chat, or you can also send it in WhatsApp. It's up to you in our group. But tell me, because you will get some interesting outputs. That is the reason I have made only these 3. I thought of like around 6 to 7, but these 3 will give you some interesting outputs. That's why I've only put 3 here. And these are my real results. Whatever that you're seeing here, 91.7%, 94.3, 83 and 87. These are after fine tuning. So when I was creating this presentation, what happened is I used this code. I got this accuracies. Then I was playing with it. I was fine tuning it. I was adjusting the parameters here and there. And finally, somehow I got 83 and 87. And confidence levels also increased to 91.7 and 94.3. So the mistake that I have done is I have not copied the code, but I have copied the outputs. So that's why the code and the outputs were a bit mismatched. These outputs that you see here are after me doing fine tuning, after changing the parameters and all. Yeah. Let's go for a break, and after that please try to do all these 3 and you will get some interesting outputs. Share it in our WhatsApp group. Yeah, see you after the break then. And any doubts anyone till here in VADER or anything? The project is done. The project is for coding wise it is short. The project is done.
I'm clear. I'm trying out the small things that you mentioned.
Yeah, sure. Any doubts you have, anyone? You particularly you have any doubt, Kaumna?
Not really.
You're trying.
I think. I'm trying.
Okay.
Yeah, I'll probably will have some after.
Yeah. If you have any, let me know.
Yeah, definitely.
And you also need that. Yeah, let's go for a break and I'll meet you after the break then. Yeah. Yeah. So I just want to go through what was the program planned and where we are right now. This was the original program. I mean, before talking to any one of you, before not even communicating, with all of you, this was the original plan of the syllabus. But as I said in the very first class, the syllabus changes based on everyone's needs. For example, timeline series project that we have done, it's not there in the entire syllabus that I've designed. But our friend required it, so we added it. The same way, I'm adding few things and I'm removing few things which are out of context for the interviews and the job. Right now, We have completed Introduction to AI and Python Foundations. Python Programming for AI is our third class and fourth class. Python libraries for AI development, we have seen NumPy, Pandas, data visualization, and we have done specific projects on it. ML and data preparation, we have learned like processing techniques, missing values, feature engineering, preparing data sets, ML, using Google Colab and how to use GPU inside Google Colab. We have seen machine learning fundamentals like supervised, unsupervised, linear regression, and also we have included time series in this. Then we have seen machine learning algorithms, what are different algorithms we have, how each algorithm behaves, what is the pros and cons of each particular algorithm. And we have also seen ML pipelines on how to create a proper project in ML. Then we move to deep learning. Actually, the next one should be NLP. But somewhere around when we are discussing this, deep learning concept came into place. Someone asked a doubt, and for that doubt, we went to deep learning. So I moved directly to deep learning once discussing TensorFlow, doing a project in deep learning. Then we came back to NLP. Tweets and here the hands-on mentioned was tweet sentiment analysis, but it was very old project nowadays. So we moved to movie reviews. After that, there has to be a midterm exam, and there has to be a midterm exam. I'll update all of you on why the exam is not updated on the portal. But yeah, what originally planned is after NLP there have to be a small exam kind of thing. After NLP, we will be moving to large language models, like what is difference between BERT and GPT, Hugging Face, and all. But for the next class, for tomorrow's class, I don't think we will be directly delving into transformers and LLMs. In between, I planned a storytelling class. So tomorrow's class is going to be more of like a small story, like a conceptual level. If you are interested, join. Like it's more of like me talking and talking and talking and talking. There won't be any code. I'll be talking about different ways you can orchestrate stories, how you present, how you not present, what is prompt engineering, what are different types of prompt engineering we have. I'll give a gist of it. So that is going to be tomorrow's class. After that, we'll be going to transformers and LLMs. And after completing that, prompt engineering I'll be covering tomorrow only. Then we'll be going to generative AI, where I'll be showing you how to integrate ChatGPT API, Gemini API, how to use Claude APIs, API integrations. That class is entirely going to be on API integration, how to create your own chatbot using third-party services like Gemini and Claude. After that, we will be introducing databases, vector databases, giving memory to your AI. After doing that, we will be finally deploying them. Deploying is some part which I've never talked about till now. Everything that we have done is in the local. So how to actually deploy your AI models into cloud is what this class is going to be on week 12. After that, before talking to all of you, that is what we have thought, like final exam and then certification and all. But before that, after this class, still we are going way beyond. This is not week 7. We are I think in week 6 or something. We are going way beyond, way forward in the syllabus that was planned. So after this class, I'm gonna integrate resume making, profile building classes, where I'll be talking about how to lie. I'll be talking how to not tell the truth without lying in the resume and into the job interviews. You will be technically not lying anything, but also you're technically not telling the truth to anyone. You will be fabricating stories in your resume. You'll be fabricating things in your LinkedIn profile for getting better reach and job interviews is what the final class is going to be on. And then you will be having an exam followed by certification, and whoever scores high, there will be, and it's not mentioned here, but there will be some of the other kind of prize that I will be giving them, which will help them in their career. So yeah, I'm just telling all this just to make sure that we are all aligned here. So I have few action items. I will make sure I'll confirm with the team why it's not updated the mid exam, and I'll update you all. And thank you, Kamala, for trying that out. Trying these three.
Yeah, no.
Yeah, that is all for today's class then. Next class, we'll talk about story. Again, next class is going to be a bit boring. I don't have anything to code or something like that in the next class. It's just going to be like a movie. I'll be just talking like a podcast. So yeah, love you all then. Take care. If anyone have any doubts in any of the concepts till now, please reach out to me. And
Monish, I have a request.
Yeah.
I am trying to kind of like integrate some of the large language models into image processing. Will there be any time for you to like kind of like, I have a project in mind, if you can give me some sort of a tips how to proceed that in any of the classes would be helpful for me.
Yeah, definitely, Kamala. Can you send me that repo or something? I'll try to make a project out of it, and I'll make it into a class.
Yeah, I'll send it to you. I'll probably send it by tomorrow or Monday.
Yeah, sure.
And yeah, if you can like sometime like just walk us through, because image processing is something that I've been using a lot, and integrating some of the models, trained models into the processing things.
Yeah, sure, Kamala. Please send it to me. I'll make it into class.
Yeah. Thank you.
Thank you, Kamala. Yeah, that's all then. I love you all. Take care. I'll see you all in the next class. Bye.
Take care. Bye.